Hello everyone, welcome to the channel TopGate. In this video, we'll see few more examples of language to grammar conversion. So in this video, I'll take up 4 different languages and I'll tell you how to convert all these languages to an equivalent grammar. So the first language that we have is the set of all palindromes of A, B. So the alphabets that we have here is A and B, and it says that the language contains all the palindromes of A and B. Clear? So if we talk about the palindromes, then we know that palindrome is any string or is any word which, if it is read from the left hand side or from the right hand side, it will be same. Clear? That means the palindrome should start and end with the same character, with the same alphabet. Clear? And the shortest possible palindrome will be epsilon here. Now apart from this epsilon, we can have A as a palindrome, we can have B as a palindrome. Why? If you read it from the left side or the right side, since there is only a single character, it will be same. So it is a palindrome. So null is a palindrome, A is a palindrome, B is a palindrome. Now apart from this A, B, what else I can have? So you can see that a palindrome, if it starts with A, it will definitely end at A. Clear? If it starts at B, it will definitely end at B. Clear? So you read it from the left hand side, you read it from the right hand side, it will be as it is. Like for example, we have say A, B, B, A. So you read from this side, it is A, B, B, A, or you read from the right side, A, B, B, A, it will remain the same. So it is a palindrome. So how can I define the rules for this one? So first string that I have is S tends to epsilon. So one palindrome I have got, that is S tends to epsilon. Done? Now, second thing is the string will either start from A or it will start with B. So if the string starts with A, it will definitely end at A. Correct? Similarly, if the string starts at B, it will definitely end at B. Now in the previous lecture, I told you that whenever we have to repeat anything, what we do, we just put this variable into the right hand side. Okay, so how can I do this? So if I have to repeat this value, what I'll do, I'll simply put S here and I'll simply put S here. So this is the required grammar for this language, that is set of all palindromes of AB. Now let's see how we can use this grammar to generate any particular palindrome. Let's see how we can do this. Now suppose the palindrome that I have taken is A, B, B, then B, B, A. So it is a palindrome. You read it from this side, you read from this side, it will be same. Now see how we can use these rules to generate this particular string. So since the string is starting from A, so I'll use this particular rule. So let's just use it. S tends to A, S, A. Done? Now next character is B. So definitely I'll use this one. So in this S, I'll put this value. So what I'll get A, then followed by B, S, B, then A. Correct? Now again, I've got AB, but after this AB, I again have this particular B. So that means again, I'll use this particular rule only. So here what I'll do, A, B, then on this S, I'll put again this value, B, S, B, and what I'm having, still I'm having B and A here. You see, we have got A, B, B, and then B, B, A here. Correct? So this is a required string. Now I need to get rid of this S also. How will I get rid? I'll get rid of this particular production rule, that is S tends to epsilon. So what I'll do, I'll just simply put epsilon here. I'll get A, B, B, epsilon, B, B, A, and the epsilon can be just removed directly. So what I'll get, A, B, B, and B, B, A. So this is the derivation for this particular string using these rules of the grammar. So for this language, all palindromes of AB, this is the required grammar. Okay, now let's move on to the next one. The next one that we have is here is L2 is equal to WCWT, where W belongs to A comma B star. Okay, now what is W here? W is any combination of A and B including null. This is the clean closure. We have already seen in the previous video. This is the clean closure. So W is anything, any combination of A, B including null. Now what is this T? T is called as a transpose. So what does that mean? That means whatever string is coming here into the first part here W, that will be in the second part of the W, it will be the exact opposite. That is, if I have AB here, then in this part I'll have BA here. Okay, so let's see an example of this one. In this one, it is saying that C should be there mandatorily. Okay, so let's say if we take say AB in W, then the string will be C, and then it will be the exact opposite of the first part of the string. So first part of the string is AB. So what I'll get? I'll get BA here. So if you read it closely, you can see that it is also a palindrome. That is, if it is ABC BA, then ABC BA. You read from this side, you read from this side, it will be a palindrome, but with an extra C in between. In this one there was no C, but in this one we have a C. So how we can just write the rules for this one? I mean, the rules will be exactly same here, but with only one extra thing, that is, we have this C here. Like in this one, the shortest string, the shortest palindrome was epsilon, but here we cannot have epsilon. Why? Because the shortest possible string in this case will be C only. Why? Because if we put this W as null, this W as null, then we are left with only C. So the shortest possible string will be C only. So for this one, I've got one rule, that is S tends to C. That means if W is null, then we'll get only this string as C. Okay, now let's see what we do for the first part and the second part of the string. So since it's a palindrome only, so what I'll do, I'll just simply write S tends to A S A and S tends to B S B. Done. So this is the required grammar for this particular WCWT language. Now let's see how we can generate any particular string. Let's see whether we can generate this particular string from these rules. So it is ABCBA. So which rule should I use? Since it is starting with A, so I'll use this one only. So S tends to A S A I'll use. Then what we have B here, so I'll use definitely this one, BSB. So I'll use BSBA, and then we have got ABBA, and then to get it terminated, what I'll do, I'll just put S tends to C. We have S tends to C here, so what I'll do, I'll simply put C in place of S here. So this is the derivation for this particular string using these rules of the grammar. Clear? So this is my rules of the grammar for the language L2, that is WCWT, where W belongs to A, B star. Okay, now let's move on to the next one. The next one that we have is L3. L3 says it is A to the power J, B to the power N, C to the power N, where N is greater than equal to 1, J is greater than equal to 0. Now if you analyze this one closely, you can see that this A can be 0. Why? Because the value of J is 0 also. So therefore this part can be 0, but this BC is never 0. Why? Because the shortest value for N is 1. Clear? So what is the shortest possible string in this case? The shortest possible string will be BC. Why? Because A can be null, but BC can never be null. Correct? And one more thing is that B and C are dependent on each other. If we are getting two B's, I'll definitely get two C's also. But this A is independent of this BC. Okay, if this BC is 2, then this A can be 0 also, it can be 1 also, it can be 2 also. So how can I write the rules for this one? So let's see. First of all, I'll just give you one example of this string. So the string we can have is, say, A, and then we have B, C. Okay, we have J as 2 and N as 1 in this one. Okay, now let's see how we can write the rules. So if you see this one, if I consider this as A and this as B, since BC are dependent on each other, A is independent, therefore for this I'll take it as A and this whole expression as B. So what I'll get S tends to A, B. Okay, now I'll define A and B separately. So what I'll do, A I'll define as, now what I'm getting in A I'm getting small a, correct? So small a I've got. Now to repeat this A, what I'll do, I'll just simply put this same variable here. So this will actually repeat this particular A, clear? And this can be null also, therefore I'll just put a epsilon here, correct? Let's go to the next one. The next one is B we have. So for B what we have, the shortest one is BC. So what I'll do, I'll just simply write BC here, And if I have to repeat this BC, what I'll do? I'll just simply write B, B, C. We cannot have null here. Like we have A tends to null. So here in B, I cannot have a null here. Why? Because the least value of n will be 1. It cannot be null. So therefore, I'm not taking null here. Clear? So this is the required grammar for this particular language. Let's see if we can generate any particular string that follows this particular language or not with these rules. So let's suppose the string that I take is say AA, and then we have BB, and then we have CC. Or you can just think of this one, A, then BB, CC. Let's see how we can do this one. So since the first one that I have is A, so definitely I'll use this rule only. So S tends to A, B, I'll use. Then in this A, what I'm having, I'm getting AA. So I'll just write AA here, followed by B here. Okay, now only one A is required, therefore I'll just put null here. So we have already got A tends to null here. So what I'll do, I'll just simply put null here. So I'll get this one. So this means A, B. Clear? Now go on to B. With B, what I have? B and C. So with B, I have these two rules. Definitely because I need two B's and two C's, therefore I'll use this one. So I'll use A, then B, B, C. Okay, now again I have to repeat it. So what I'll do, I guess because only two B's are required, so I'll just simply put this one in this B. So I'll get A, then B. In this B, I'll put this BC. So B, C, and then this is the C we have here. So we have got the string A, B, B, C, C using these rules of the grammar for the language L3 is equal to A, J, B, N, C, N. Now let's move on to the fourth one. The fourth one that we have is here is L4, and this L4 is A to the power N, B to the power N, C to the power I, D to the power J, where N is greater than equal to 1, I is greater than equal to 0, J is greater than equal to 0. Now if you analyze this one, you can see that this A and B are dependent on each other. If A is 2, B will be 2. Clear? Because both are having the same N value. Clear? C is I, that can be 0, D is J, that can be 0. So C and D are independent of each other, as well as they are independent of A, B also. Clear? So we can just try to understand this as a single expression, this is as a single one, and this is as a single one. So I can have S tends to A, B, C. That is A part, B part, C part. Done? Now, next one is I'll define A, I'll define B, I'll define C. So let's define A. So in A, because I can see that this part can never be null, but this part and this part can be null. Okay, so for B and C, I'll put epsilon also, but for A, I'll never put epsilon. So what I'll do, I'll just, because the shortest possible string will be A, B, and if I have to repeat it, what I'll do, I'll just simply put A, B. That is, I'll just put this variable in between. So this A, B will be repeated n number of times. Done? Now, define B here. So for B, what I'm getting, we have this C, and if we have to repeat this C, what I'll do, I just simply put this variable here. So it will be CB, and since it can be null, therefore I'll just put null here. Clear? Now let's define C also. So for C, what we have this D, and since we have to repeat this D, therefore I'll just put this variable here, that is C, and since it can be null also, therefore I'll just simply put epsilon here. So this is the required grammar for this particular language L4, A, N, B, N, C, I, D, J. Now let's see if we can derive any particular string using these rules or not. So let's say we have a string as say A, B, B, and C, D. Okay, now let's see how we can do this one. So A, B, B, C, D. So I'll just use this rule, S tends to A, B, C, because any string which has to be derived should be derived from the start symbol only. So S tends to A, B, C. Now in A, what I want this two A's and two B's. Definitely I'll use this one first. So it will be A, B, and then B, C. So this I'm expanding this time. Clear? Again, I need one more A and B, so therefore I'll use this rule now. So I'll get A, then again A, B here, then B, and then B, C here. Clear? So this A, B, B we have got. Now we have to use this C and D. So I'll now expand this one B. So this will be A, B, B, and then I will use this rule. So I'll get C, B, and then capital C. Clear? Now I need only a single C, therefore in this B I'll put this null value here. So I'll get A, B, B, C, and this is gone. I'll get capital C now. Okay, now I need one D, so therefore I'll move on to this one. This C will be expanded now. So what I'll get, A, B, B, C, and then here I have this D, C. Clear? And since I need only one D, therefore I'll use this rule now. So I'll just put a null value here. So A, B, B, C, D, and this is gone using a null value. So this is the string that we required, that is A, B, B, C, D, and this is the rules of the grammar for the language L4 is equal to A, N, B, N, C, I, D, J. So I hope this is clear to you now. Thank you so much.